There's one last type of complex fraction that we haven't talked about. Now when I look at this example, it doesn't look complex. It just looks like there's negative exponents. But remember what a negative exponent does. If I have x to the negative second power, a negative exponent takes the reciprocal. So each one of these terms with a negative exponent, I have to take the reciprocal of just the piece with the negative. So for example, 2 times x to the negative first, that 2 does not have a negative exponent. Just the x has a negative exponent. So my first step is to rewrite every single term with a negative exponent. The 2 does not have a negative exponent. It stays in the numerator. I take the reciprocal of x to the negative first power, which is just x to the first, but now in the denominator. Same thing with this 3 times y to the negative 1. The 3 stays in the numerator because it does not have a negative exponent. The y drops down to the denominator. Now those are just the fraction or the terms in the numerator. I also have to do this with the terms in the denominator. And because of this plus and minus here, they don't flip directly within that fraction. So because I have a sum and a difference, I can only take the reciprocal within the numerator itself. In the denominator, the reciprocal of x would just be 1 over x, right? This is x to the first power, now it's in the denominator, minus the 2 does not have a negative exponent. The y gets moved down to the denominator. So this is how we can rewrite terms with negative exponents with a sum and difference. They become complex fractions. Now looking at this, the LCD of the numerator would be xy. The LCD of the fractions in the denominator would also be xy. So I'm going to go ahead and use method 2 on this since they have the same LCD. We found the LCD of xy. So I take everything in the numerator times xy and everything in the denominator times xy. This is like multiplying by 1, right? Xy over xy is just 1. But I need to make sure I distribute it to both terms. So if I multiply 2 over x times xy, the x's divide out, but I still have a y. So now I have 2y. Plus, same thing when I do the 3 over y times xy. The y's divide out, but now I still have an x, so 3x. In the denominator, I also distribute that xy. So 1 over xy times xy, the x's divide out, I'm left with a y. 2 over y times xy, the y's divide out, and I'm left with a 2x. I look at what's left. I see if there's anything I can factor out at all. I don't see anything. No difference of squares, no GCF. This is as far as we're going to be able to go. Go ahead and try the example on the right. Alright, first step when I see negative exponents, take the reciprocal of every term that has a negative exponent and just the factor that has the negative exponent. So 1 is a whole number, I leave it alone. 2 times x to the negative first power, the 2 stays in the numerator, the x gets moved down to the denominator. Minus 15 stays in the numerator, and x squared gets moved down to the denominator, right? So this does not have a negative exponent. Only the x has a negative 2 exponent. We take the reciprocal, it moves it down to the denominator. Now it's a positive 2 exponent. In the denominator, 1 stays the same. The 3 stays in the numerator, and the x to the negative 1 power becomes x to the first, in the denominator. Alright, now I have a complex fraction. Fractions within fractions. I look at the least common denominator. I have an x, x squared, and an x. If I take the highest exponent, the LCD is x squared. I will multiply everything in the numerator by x squared and everything in the denominator by x squared. Again, I chose to use method 2 here. So 1 times x squared is just x squared. X squared times 2 over x. One of the x's will divide out, and I'll still have one left. Right? So 1 will go away. I'll still have 1 to multiply by the 2. And x squared times 15 divided by x squared. X squared itself divides out, and I'm left with just the negative 15. Same thing in the denominator. X squared times 1 is just x squared. X squared times 3 over x. One of those x's divides out. I still have 1 left with the 3. From here we factor. So in the numerator, I want factors that multiply to negative 15 and add 2. Again, I know this because it's a trinomial. So multiply to negative 15, add to 2. I'm thinking 3 and 5. One of them needs to be negative to multiply to a negative. I'm going to put the negative with the 3, so it will add to a positive 2. The leading coefficient is 1. I can go right into my parentheses. X minus 3, x plus 5. All over. In the denominator, if we have a GCF, we start with GCF. So I take an x out, and I'm left with x plus 3. I do not see any common terms. These look close. I have an x minus 3 and an x plus 3, but they're not like. There's nothing here that I can do. So this is as far as I can go. I cannot simplify any further. Now if this had been a negative here, then there would have been a negative here, and then the x minus 3's would have divided out. So make sure that you are factoring and checking for common factors before you decide it's as simplified as possible.